Good morning, students. Today we will continue the chapter number 5, that is inside the atom. Before going to the further topic, let's recall the points which you have completed in the previous class. We studied about atoms, compounds and elements. Also, we have studied about the theories given by scientists such as John Dalton's atomic theory, then Rutherford's nuclear model of an atom, and also Sir J.J. Thomson's plum pudding model of an atom. But in due course, Rutherford's atomic model was quite unsatisfactory when it came to explaining the structure of an atom. It was not appropriate. But children, what was the reason which termed it as incorrect? Let's see that. Now, we know that any charged object which revolves in a circular motion, it gains acceleration. That is, the speed increases. And if the speed increases, it is very obvious that it will give out energy in some or the other form. Now, if it is continuously keeps on radiating energy, then definitely all the energy of an electron gets over and it will fall into the nucleus, causing into a high instability of an atom. But wait a second, all these things do not happen in an atom except some radioactive elements, because in nature all atoms are stable. That means the theory put forth by Rutherford was it incorrect? Is it? No, actually it wasn't incorrect, but it needed a little modification, and this modification were made by the next scientist, Niels Bohr. Niels Bohr performed certain additional experiments to describe the atomic structure. The postulates put forth by Niels Bohr was as follows. The first one is the electrons revolving around the atomic nucleus lie in the concentric circular orbits at certain distance from the nucleus. And the second theory was the energy of an electron is constant while it is in a particular orbit. That is, the electrons do not radiate energy. Now, children, these are the points exactly tells us that why the atoms are stable. But children, what exactly these orbits are in which the electrons revolve around the nucleus? Let us understand with an example. Now children, do you know how our solar system is? Yes, it appears somewhat like this, solar system. Now in this, the sun is stationary. The sun is in the center, and the remaining different planets, they revolve around the sun in a particular orbit, in a fixed path. We never find any of the planet jumping out of the path all of a sudden, right? They always revolve in a definite path. In a similar way, we also have the atomic structure. The nucleus acts like the sun. This nucleus, it acts like the sun, which is located at the center. And the electrons, they act like the planets, which revolve around the nucleus in a fixed definite path. These orbitals are referred as shells. The orbitals which you can see, the circular orbitals, they are called as shells or the energy level. Now Niels Bohr suggested that the electrons revolving in the orbitals do not radiate energy because each shell has got a defined energy level. That means when the electrons revolve in each shell, they do not liberate any form of energy. Now let's see that how these shells are named to indicate their position. So now naming the shells beginning from the orbitals which is near the nucleus is named as K shell. The next is L shell, M shell, N shell, and so on. And what if we want to number them? If we want to number them, the first shell is referred as N is equal to 1, and the second shell N is equal to 2, M, N is equal to 3, 4, and so on. So, after studying the structure in depth with the help of quantum mechanics, some fundamental principles of atomic structure was given, and that atom contained the three different types of subatomic particles. Let's see what are they. Now let's see the structure of an atom. Here you can see the positively charged nucleus which is densely concentrated in the center, and the nucleus contains two things, that is protons and neutrons, which are tightly packed. Also, the atom consists of mostly the empty spaces which you can see here, the empty spaces, and the electrons which are rotating here, revolving here, they are revolving around the nucleus in a fixed orbits or path. Now let's study about them in the detail. Now first here we will see the proton. Now the proton, they are positively charged and was discovered by E. Goldstein. Proton has 1 unit mass. The protons have a positive electrical charge of 1.602 into 10 raised to minus 39 coulomb. The charge is equal but opposite to the negative charge of the electron. A proton's mass is about 1840 times the mass of an electron. Therefore, the proton carries a positive charge of +1, exactly the opposite electric charge as electrons. The number of protons in the nucleus determines the total quantity of positive charge in an atom because the protons are positively charged. The next we will see about the neutrons. The neutron was discovered by Sir James Chadwick. Neutron is slightly heavier than proton and 1838 times as heavy as electron. Neutron electrically neutral elementary particle that is part of the nucleus of an atom. The neutron is about 10 raised to minus 13 centimeter in diameter and weigh up to 1.6749 into 10 raised to minus 27 kilogram. Next we will see about the electrons. Now electrons were discovered by Sir J.J. Thomson, as I have told you in the earlier video. Now electrons are negatively charged particles around the nucleus of an atom. Each electron carries a single fundamental unit of negative electric charge, that is 1.602 into 10 raised to minus 9 coulomb, and has a mass of 9.109 into 10 raised to minus 31 kilogram. The electron is one of the lightest particle with a known mass. Electrons cannot be split into anything smaller. Also, electrons do not have any real size, but instead the true points in space, that is, the electron has a radius of 0. That means in the nucleus, the mass of the atom depends on the protons and the neutrons totally, because the electron's mass is very negligible. Moving further, children, we will see the atomic mass number. The mass of an electron is negligible. Therefore, the mass of an atom is mainly due to the protons and the neutrons which is present in the nucleus, which is situated in the center. Hence, the total number of protons and neutrons is called as the atomic mass number, and it is denoted with the symbol A. Now, with the help of this formula, we can show the atomic number as well as the mass number together of any atom. We can understand what is the atomic number and which is the mass number. Now, here I am taking the example of a carbon atom. Now, in this carbon atom, it shows that the total number of proton and neutron is 12. That is, A is 12 and the number of proton is 6. That is, Z is 6. Hence, the number of neutron will be 12 minus 6. That is 6 neutron. Now, children, here I am giving the exercise. In this, the bromium atom is given and you have to find the answers for each one of the questions here. And write your answers in the comment section, children. I will check it. Now, finally, children, we have the complete design of an atom. In the center lies the nucleus, which is having the positively charged protons, the neutral neutrons, while the negatively charged electrons are moving around or revolving around in a fixed orbitals. But children, how exactly are these electrons distributed in the orbitals? They are moving in the orbitals, but are they moving randomly or do they have a particular formula for the distribution? Let me give you an example of the atom of an oxygen atom. Now, oxygen atom looks somewhat like this. Now, in the oxygen atom, the first shell, that is the K shell, it is having 2 electrons. The second shell, L shell, it is having 6 electrons. Now, they are not evenly distributed, children. Now can we distribute evenly as 4 electron in the first shell and 4 electron in the second shell? No, it is not possible because the electron cannot be present randomly in any shell. There are specific rules to allocate the electrons in the shells. Let's understand this rule. Now, the rule for distribution of electron is using the formula. Now, formula is 2 into n raised to 2, that is the power 2. Now, here the n denotes the shell number. Now, if we will take the example, now here in this, the first shell is the K shell. The number of the K shell is 1. So, we will substitute the number 1 in the formula, or this formula 2 into n raised to 2. So, 2 into 2 raised to 2, 1 raised to 2, that is 2 into 1, it is equal to 2. That means the K shell has the capacity to hold only 2 electrons, not more than that. They cannot accommodate more than 2 electrons in them. At the same time, if we are taking this formula and we are substituting the value in the formula for the L shell, this is the L shell and it is the number 2. If I will take 2 here, it will become 2 into 4 and the answer will be 8. That means the maximum capacity of the L shell to hold the electron is 8 electrons, not more than that. So, it can accommodate only 8 electrons. In the same manner, for the M shell also, M shell, that is the third number of the shell, and that third number of, if we are substituting the value 3 raised to 2, here we will get the answer 18. That means the M shell can accommodate only 18 electrons. The capacity of the M shell is to hold 18 electrons, not more than that. In the same manner, for the N shell, which is the fourth number of the shell, and that 4 is distributed here, and when we will substitute the value, we will get the answer 6, and the answer we will get 16. Here after multiplying, we will get the answer 32. That means the N shell, this is the fourth shell. The fourth shell, N shell, can hold 32 number of electrons, not more than that. It can accommodate only 32 electrons. So children, I hope you have understood the distribution of electrons in the different shells. In the first shell, it is number 2 electrons can accommodate. It has only 2 capacity. Now here it has a capacity of 8. This N shell has a capacity of 18, and this N shell has a capacity to hold 32 electrons. Now children, on the basis of that explanation, you are going to fill this table. Now in this table, the columns which are given is the electron capacity of the shell, and here it is shell. Here it is given shell, and here the electron capacity of the shell. Now we know that the first is the K shell, then L shell, M and N shell, and on which position they are. The K shell is on the first position, L is on the second position, M is on the third position, N is on the fourth position, and this position we will substitute in the formula. As I have told you, the formula is this: 2 into n to the power 2. Now when it is the first shell, we are substituting the value that 1 here, and then the number of electrons we will get here is how many? Yes, if we will get 1. Here if we will substitute the value, we will get the number of electron. As I have told you, just now I have shown you. The same way you are going to do this, and this table, children, you are going to write down in your notebook along with the notes. Now we will stop here. The remaining topics we will see in the next lecture, the next videos. Children, till then, read your lessons thoroughly till where I have completed the explanation. Also, the assignments which I gave you just now in this video, you have to write down in your notebooks also, and write the answers, put your answers in the comment section also. Till then children, bye, take care.